Hello. So this is a video about threads, a whole new topic. It's not really data structures per se, but it is necessary to do multi-threading, concurrency, all sorts of reasons for using threads. So we're going to talk about the basics of threads, and then we're going to get into problems that threads cause and how to fix them. So there are basic processes, and then there are sub-processes called threads. In Java, they're pretty much indistinguishable on the surface, but a process has an entire environment, and a thread runs within a process. Now, most of our modern computers have 8 cores. A core is a hardware term that is, and all the computers in the classroom have 8 cores. My laptop has 8 cores. Probably yours has 8, maybe 4. Maybe if it's really old, it might only have a single core. So, but first let's talk about how a thread executes in a single core. And then you can generalize to how multiple processes or processors can execute. So a process is a self-contained execution environment. It's self-contained. It has its own memory space. All the things we talked about in the memory management lab apply to each process. Sometimes, and the applications you've built so far generally use a single core, use a single thread. Now there are cases like graphic user interface GUIs that automatically create or use a separate thread. But there are some applications, a lot of applications, that cooperate with other processes. And those cooperating processes use such things as pipes and sockets, which will IPC resources that we'll talk about next week. So a thread is sometimes called a lightweight process. It executes inside of an existing process. So there's one process for every application at least, and then you could spawn more threads within it. Every process has a basic thread that it runs, and then there could be others. There are also a number of system threads, operating system threads, that do memory management. The Java virtual machine has threads that does memory management and signal handling and garbage collection. So a single-threaded program has sole control of the process until it ends. It might wait for user input or input-output, but nothing else occurs in the Java virtual machine, except possibly some system threads interrupted and swap in. Here's a chart of an example of a single-threaded program. Runs for a period of time. It swaps out. That's the word, the term that's used commonly. I don't know if it's official or not, but it's so. The time that the thread is running is called busy, and then it's swapped out, and then it swaps back in. Now, a single core, a single execution core, could still appear to be multi-threaded to give the impression of parallel execution, because when one thread is swapped out, another thread could be swapped in. So this diagram at the bottom of the chart shows two threads, P1 and P2, running. P1 runs for a while and then it swaps out, and then P2 is swapped in. So we do not know when a specific thread will be swapped in or swapped out, because that's an operating system feature. So the operating system, which is underneath, beyond even the Java virtual machine, it's more basic than that. It has a thread scheduler, and its job is to run each thread for a short amount of time, which is called a time slice. And then the scheduler activates another thread, and if it's a single core machine, the thread that's been running will swap out. So that means, because the thread scheduler is an operating system feature, it means there will always be slight variations in the running times. So the operating system might call input and output, and so there's no guarantee about the order in which threads are executed because of this operating system thread scheduler. So if you were creating a multi-threaded program, you might use, this is just one example, you might use 4 different threads, one for the GUI, which is automatically created when you start a GUI, one for processor heavy tasks, which would probably be the main method, and input and output might run in another thread, and then animation might run in a 4th thread. Okay, so how do you create a thread? So first of all, there is an interface called Runnable, and Runnable, the interface, has a method called run, which you are required to implement if you implement Runnable. So here are the Java doc for Runnable interface. Any class whose instances are intended to be executed by a thread have to implement Runnable, and because they implement Runnable, they have to implement the run method. Okay, so here's an example. My Runnable is just the name that is given to the class. It doesn't have to be that. It could be anything, but it has to implement Runnable. And anything that's going to happen in the thread has to go in the run method. Just like many other situations we've encountered, start for GUIs and handle for GUI processes. So once you've got the Runnable class, my Runnable over here in the very top in section 3, so then you create an object from that class. In this case, R is a reference variable that points to a new myRunnable class object. And then we create, fourthly, the 4th bullet, we create a thread object from the Runnable object. So we put R, which is this Runnable class object, we put it inside a thread and create a new thread with that Runnable class inside it. We call it T in this example. And then we call T.start. So T.start starts run executing. Remember, run is inside my Runnable. So those yellow boxes explain how to create a thread. And you'll need to follow that directly when it comes time. So let's talk about the life of a thread. Before the thread before you call T.start, the thread just sits there, it doesn't do anything. When you call T.start, then the thread, in our case R.run, starts executing, and it's alive until the run method terminates. and then the thread is dead. So here's a program, a simple program to print a timestamp, and once a second for 10 seconds. So the way that we space out this method is to call thread.sleep, a static method, which takes as arguments milliseconds. Now there are 1,000 milliseconds to each second, and so this is approximately a second. If you say 1,000, thread.sleep with 1,000, it's approximately 1 second. If this is the only thread running, it'll be pretty close. So when the run method terminates, then the thread terminates. Now there's an old method called stop. It's deprecated, which means that there's a better version, and it's in there for reverse compatibility, but basically nowadays we use t.interrupt. T is still referring to the thread, and interrupt doesn't cause a thread to terminate, it just gets its attention, and it sets a Boolean variable that allows you to test it. Usually the thread terminates when interrupt happens. So interrupted, the method, tests whether the thread has been interrupted, and it's a Boolean variable, returns a Boolean. So here's one way of using the interrupted method. You could start run. Remember, everything that happens inside run, and you call it with a certain number of repetitions. And you loop through until I is either less than the number of repetitions you ask for, or thread.interrupted returns false, or returns true. So that's one way of terminating a thread. But another more standard way is to account for the sleep method throwing an interrupted exception when a sleeping thread is interrupted. And I'll show you the details of that in a minute. So suppose you have this thread and you say sleep a certain amount, say 1,000 milliseconds, 1 second. But then you have to account for the fact that it might get interrupted in the middle of the sleeping. If so, then the cleanup, you catch it with a try catch, and then you clean up and return. So Java doesn't force a thread to terminate when it's interrupted. It's entirely up to the thread what it does when it's interrupted, but normally we kill it. So here's an example of some code. This is greeting Runnable. It implements Runnable, so it has to have a run method. Here's the run method down here, and the run method has a try catch. We don't see, there's no driver here, so we don't see the interrupt happening. We also don't see the start method. But now we have this class, and it is set up to exit once an exception happens. And so now we create the runnable object with hello world in it, and we create the thread and we start it. Now suppose we have two threads. This is the big picture here. So suppose we have R1 and R2, and we create two threads which is why there are threads in the first place, is to do things in parallel. And then we start both of them. Now these are exactly like the original greeting runnable. But now wait, we have a problem because it doesn't, because of the operating system scheduler, thread scheduler, things don't happen exactly in the right order. Notice even though we had 1,000 milliseconds as our sleep time, run 1 started out with Goodbye World, and then Hello World came on in the second place. And furthermore, in the second run, things are in a totally different order. So this is a problem, and we'll have a way to fix it. Here's another example of 5 threads. In this case, it's run inside a for loop, or here's the for loop. And there are at least three different sets. I don't know what 5, combination of 5 at a time is. Anyway, there are at least 3 different orders that are shown here. Now, if you just decided to do R1.run and R2.run, you would just print out 10 versions of R1, and then you would print out 10 versions of R2. All right, so here's some code, and this has a driver. It's called My Runnable Runner. It's the driver, and it interrupts. It starts each thread and then interrupts it. So let's look at how this happens. So run. So My Runnable starts in a thread. Run starts happening because it's t.start is called. And the first thing it does is print 1, the integer 1. And then it sleeps, goes to sleep for 1 second. Now, does it print line 2? No, it never gets there, because immediately after the start, interrupt is called. Well, now, you got to remember that the computer is so much faster than human thought that a second is nothing. That's why they use milliseconds as the argument for sleep. So it's certainly going to get interrupted and in the middle of sleep, and then an interrupted exception is going to get thrown by sleep because it's interrupted in the middle of sleeping. And so it's caught here, and so 1 prints first and then 3. And then at the end of the catch, it prints 4. So 1, 3, and 4 is the order that gets printed. Okay, so that is the basics of how to start a thread, start multiple threads, and why they can't be predicted to run in any certain order. So we have a problem, though, and we'll talk about that in the next video. We have several problems, and we'll discuss that in the next video.